Okay, now we're going to look at functions defined by equations. We looked at functions that were defined by tables and graphs last lesson. Now we're going to look at ones that are defined by equations. And this is probably a little bit more familiar to you than what we just did. So tickets to the senior class play cost $5. Production expenses are $500. The class's profit P will depend on N, the number of tickets sold. So the profit is equal to $5, because that's the cost of a ticket, times the number of tickets that they sell, minus the $500 that they already spent. So here is what our equation looks like. P equals 5N minus 500. If I was going to write this as a using function notation, I could say P of N equals 5N minus 500. And we're going to talk about function notation in just a little bit. The equation P equals 5N minus 500 describes a correspondence between the number of tickets sold and the profit. So the profit depends on how many tickets are sold. Okay, so profit is a function of number of tickets. This correspondence is a function whose domain is the set of tickets that could possibly be sold. Okay, so the domain is D0, 1, 2. Notice that there's no negatives because you can't sell a negative amount of tickets. There's no decimals or fractions because you can only sell a whole number of tickets. You can't sell like half of a ticket. That doesn't work. So this is the restrictions on my domain. The range is the set of profits that are possible, including negative profits. So basically, we would plug in the numbers for the domain and come up with our range. So if they don't sell any tickets, their profit is minus $500, or basically a loss. If they sell one ticket, their loss is only $495. If they sell two tickets, it's only negative $490. And then it goes up, and eventually they'll get to a point where they're what we call break even, where it's zero, there's no profit, there's no loss, and then from that on, it's going to be profit. Okay, if we call this profit function P, we can use arrow notation and write the rule. So this is what arrow notation looks like. P, then colon, then N with an arrow. So this is basically, we're saying that P is a function of N, and this is the situation that we use to solve P. We read this, the way it's read is, the way it's said, the function P that assigns 5N minus 500 to N. That's one way to say it. Or the function P that pairs N with 5N minus 500, okay? We don't like saying this because it's a mouthful of words, but you're going to see this quite a bit, especially when you get to like certain physics courses and calculus and stuff like that. But basically, it's the same as this. It's the same, this right here is the same as this right here, okay? And this is P of N equals 5N minus 500. And we call this function notation. We're basically saying that P is a function of N when we have 5N minus 500. So this is the actual function. And so we want to know that we know that P is a function of N. Okay, which is read P of N equals 5N minus 500, or the value of P at N is 5N minus 500. Okay, so this is what we look at the most. The value of P at N. So the value of P when N is, and then we put in whatever number we're going to use for N, and then we plug it in there. To specify a function completely, you must describe the domain of the function as well as give the rule. The numbers assigned by the rule then form the range of the function. Okay, so this says list the range of, and remember this is just like having g of x, where we have 4 plus 3x minus x squared if the domain is. So they have to tell me what the domain is in order for me to figure out what the range is. So here my domain consists of only 4 numbers, negative 1, 0, 1, and 2. This is my function, okay, and it looks kind of weird because it's backwards, but it doesn't matter. And what we're going to do is we're going to plug in this value for x into the function to find out what the range is going to be. So in this case, we have 4 plus 3 times negative 1 is going to be negative 3, minus negative 1 squared is just 1. So 4 plus negative 3 is just 1. 1 minus 1 is 0. So my first range value is 0. Okay, I'm going to put this equals 0 here. If I plug in 0, I have 4 plus 0 minus 0, which is 4. So my next range value is 4. If I plug in 1, I have 4 plus 3 minus 1, which is 6. So there's my next range value. And if I plug in 2, I have 4 plus 6 minus 4, okay, because it's the x that's being squared, not the negative. So this is going to give me 6 as well. Okay, but because 6 is twice, I'm only going to write it one time. Okay, we don't write 6 a second time. We just write it. So my range is 0, 4, and 6. Okay. Note that the function g in example 1 assigns the number 6 to both 1 and 2. I just said that. In listing the range of g, however, you name 6 only once. So if you have repeating numbers, you don't list them. You just list them one time. Okay, if you have numbers that repeat. Members of the range of a function are called values of the function. So the range is the values of the function. This is the range. In example 1, the values of the function g are 0, 4, and 6. To indicate that the function g assigns to 2 the value 6, you write g of 2 equals 6. Okay, so whatever my function is, g is my function, or the g of x or whatever we used. When x is 2, when I plug in 2, when 2 is my input, my output is 6. So this is how we would write that, which is read that g of 2 equals 6, or the value of g at 2 is 6. Remember that g of 2 is not the product of g and 2. We're not multiplying this. This is just another way of writing y. It names the number that g assigns to 2. Okay, so here we're given this function of x, x squared minus 2x, with the set of real numbers as the domain. So they want to know, what's the value of f when x is equal to 4? Okay, so this is how we solve for f, and this is your x. So they want to know, what's the value of f when x is equal to 4? Well, I can plug in, and I get 4 squared minus 2 times 4, which gives me, 4 squared is 16. That's a squared, not a 42. 16 minus 8. So f of 4, the function of f when x is equal to 4 is 8. Okay, so this is the value of the function when x is equal to 4. Okay, see how that works? I'm not multiplying that. So here I have f of negative 3 is equal to negative 3 squared minus 2 times negative 3. So f of negative 3 is equal to 9. This is going to be plus 6. So when the value of x is negative 3, the function is equal to 15. Okay, and then we do the same thing with 2. F of 2 is equal to 2 squared minus 2 times 2. So f of 2 equals 4 minus 4. So the value of the function when x is equal to 2 is 0. Okay, so this is just called function notation. Notation is how you write something. Okay, so this is function notation. Okay, you may use whatever variable you wish to define a function. For example, g of t for the function t squared minus 2t with the set of real numbers as the domain is the same function as f in example 2. So here I had f of x. Here I'm having g of t. It's just different variables, but it's the exact same function. See, t squared minus 2t, x squared minus 2x. Okay, so I can use whatever variables I want. And usually we have variables that represent something. Okay, so maybe t is time, or p is pressure, things like that. Okay, so let us find the range of each function. So here's my function. Okay, and this is my domain. So if I plug in negative 7 for x, I get 3 times negative 7 minus 2, which is equal to negative 21 minus 2, which is equal to negative 23. So the value of the function when x is negative 7 is negative 23. The value of the function when x is 0, I have 3 times 0 minus 2 is equal to negative 2. So I write f of 0 equals negative 2. And then, let me circle these. I have f of 5 is equal to 3 times 5 minus 2. So f of 5 is equal to 15 minus 2 is 13. Okay. Here I have the same thing. This time I have g of x. So when I have g of 2, and I'm not going to write it all out, 2 squared is 4. 4 plus 2 is 6. And then 2 minus 3 is negative 1. So that's negative 6. G of 4, I have 4 squared is 16 plus 2 is 18. and 4 minus 3 is 1, so that's 18. And then g of 5, I have 25 plus 2, which is 27. 5 minus 3 is 2, so that would be 13 and a half. Okay, so that's how I write those. All right, and our last one, which is on the next page, find the values for each given function. So this is basically what we've done. So I'm just going to plug these in. So if I plug in -1, I get -1 squared is 1, 1 plus 1 is 2. If I plug in 0, I get 1. If I plug in 2, I get 4 plus 1 is 5. If I plug in -1 here, this becomes -2 plus 1 is -1, so 12 over -1 is -12. If I plug in 0, this becomes 1, so 12 over 1 is just 12. If I plug in 3, I have 6 plus 1, which is 7, so this is 12 over 7, which is 1 and 5 sevenths. Yeah, okay. So that is function notation, functions defined by equations.